It is, yeah. So I have two sides and I want a side, so I'm going to use Pythagorean theorem. So I've got a squared and b squared and c squared. This c is always the hypotenuse, it's always the longest side. So in your calculator, 8 squared plus 13 squared equals c squared. So in your calculator, hopefully you're doing this. 8 squared. Oops. Happens when I try to type one-handed. 13 squared. So is my answer 233? Why not? I do have to square root it. So when you square root it, the answer hopefully is 15.26. How is number 3 different than number 2? Absolutely. So we're still going to use Pythagorean theorem. Go ahead, Victoria. Exactly. So it doesn't matter if this is A and this is B or the other way around. We can just do x squared plus 7 squared equals 9 squared. Some people have already generalized that if you're looking for a leg, you're really subtracting. So you can do the hypotenuse squared minus the leg that you know equals the other leg. So either one of those formulas will work. It doesn't matter which one you do, because if you choose this one, the first thing you're going to do is subtract that 7 from both sides. So in my calculator, I'm going to change my 8 to a 9 and my 13 to a 7, and I'm going to subtract. So is my answer 32? Why not? I got to square root it. I keep asking that question because that's the most often the reason somebody gets this kind of problem wrong. My answer is going to be 5.66. Question number 4 takes this to a whole new level, right? This is still Pythagorean theorem. What kind of triangle is that? So it's like two right triangles stuck together, right? Are they congruent? Yeah, it's definitely bisected. And I've got this tick mark on the left and a tick mark on the right. So what's the hypotenuse of the right triangle on the right? 24. And if this truly is bisected and we have the right angles that we talked about in our warm-up today, what's the length of this bottom piece of the right triangle? Yes, I'm cheering so loud for you right now. So how do I find x if I know 24 and 11? Absolutely. Absolutely. So the tricky part here is recognizing that it's 24 and 24 and that this has been bisected. So you can do half of 22 as 11 and 11 over here. Does that make sense? This is definitely kicking Pythagorean theorem up a couple of notches. And then you can come over here and pull this down and see if you got the right answer. 5 is very similar to 4, but it does make just a little bit of a difference. How is this triangle different than the one we just did? It is. So what do I know about equilateral triangles? All angles equal 60. So I know that's 60 and that's 60. And if I remember from the last one that these are bisected, what are each of those? Nice. Okay. So I know all the angles are 60. What do I know about the sides of an equilateral triangle? Absolutely. So I've got my tick marks there, right? And equilateral triangles, if all the angles are the same, then all the sides are the same. So shouldn't this bottom one be 16 too? Uh-oh, my internet is unstable. If I lose you guys, I'll reconnect, okay? So we know that this is bisected. So what's the distance halfway across that triangle? Are you guys still with me or am I frozen? 8, okay. So I know both the sides are 8. So now it's the exact same problem that we had before. We just had to know some of those definition things in order to be able to figure that out. So now basically I have a triangle where the hypotenuse is 16, one of the legs is 8, and I want to know what the other leg is. Can I do the same thing I did before? Yep. And then our answer should be here, 17.89. Am I going too fast or are we okay? Okay. I wanted to go kind of fast through the Pythagorean theorem because I think most everybody has Pythagorean theorem and I want to make sure we have time to get to the inverse. What do I do in number 6? If all I have is words, what do I have to draw? A picture. What kind of picture should I draw? What shape? A right triangle or a exactly. So he's building a rectangular deck. So I'm definitely going to draw a rectangle. But then I cut it in half because it wants to know the length of the diagonal. That's where my right triangle comes in. So really, I'm drawing 2 right triangles on top of each other. When I have a rectangle, I've got 2 short sides that are equal, 2 long sides that are equal, and then the diagonals, in this case, are my reflexive side. And I've got right angles everywhere because it's a rectangle. So what is the length of the diagonal? I need to mark some stuff, though. Where do I put the 10 and the 23? Exactly. So my drawing shows that the height is smaller than the base. So I'm going to put the 10 and the 23 there. But does it really matter? Not really. Exactly. So we're looking for that hypotenuse, that C. So we're going to do what math? What do I put in the calculator? Uh-huh. So what do I type into the calculator? And then what do I have to do for my last step? First, take the square root. I've never tried to put the square root after I've typed the number. Oh yeah, it doesn't work. Boom. Yeah. Mm-hmm. Oh, did I do something crazy? Maybe I did something crazy. Let's check it. You're right. It can't be 17.89 because that would not 16 squared minus 8 squared, 13.8. Thank you. And we'll do that. 13, maybe 13.9. Sweet. Did I make any other mistakes? I make them all the time. Okay. Well, call me out just like you did, okay? You see anything crazy? Because I found actually a mistake on slide 8 when I was reviewing it. So how do I decide whether it is a triangle? So this is just review. Is it a triangle? What do I do? Absolutely. So 3 plus 7 has to be bigger than 9. Does that work? Yep. And then how do I decide if it's a right triangle? Boom. And then on the next slide should be your answers. Hopefully I did all of these right. So all of these are triangles except for this one, because 4 plus 11 is not bigger than 16. It's smaller. And then none of these except the 20, 21, 29 are right triangles, because a squared plus b squared does not equal c squared. Right? So remember, is it a triangle? Small plus medium is bigger than large. Is it a right triangle? A squared plus b squared equals c squared. You've got to read super carefully. If your eyes glance over the word right in one of these questions, then you're going to answer the wrong question and you're going to get a wrong answer, right? Half the battle in geometry is answering the question that's being asked. Number 9, it's kind of like the one that we did on the warm-up today. So I know for sure this one works because it was on our warm-up. 21 squared plus 20 squared equals 29 squared. Do any of the other ones work? It was. So for all of the other ones, you just need to test it. And some of them are close. If this was 8, 6, 10, that would be a right triangle. If this was 3, 4, 5, that would be a right triangle. And 5, 12, 13, that would be a right triangle. Those are Pythagorean triples, and they're just something that eventually you memorize if you do enough right triangle stuff. So that is the right answer. Again, all of these blue background slides are going to be Pythagorean theorem. So when you go to take your test, and I'm hoping that you guys will feel confident at the end of the day to take the test. We'll see. If not, we'll practice some more and we'll do it on Tuesday. But how would I approach this one now that we're feeling a little more confident? Okay. Sweet. So one of the first things that I do is I just square all the numbers. I know it's a right triangle. I know I'm going to use Pythagorean theorem. So I know eventually I'm going to have to square everything. Can somebody do 24 squared for me and somebody else do 26 squared and tell me what those numbers are? Because I'm being lazy. Sweet. Thank you. So then it just becomes a matter of what Naja's saying and figuring out which two things add up right. So if you try that, it doesn't quite work. So maybe I need something smaller. So 100 plus 576 definitely equals 676. And it's just trial and error. Mm-hmm. So as long as there's only 4 choices and you know you're going to use 3, it doesn't take that long. It's just a matter of putting in the effort to do the work. So those 11 slides are all Pythagorean theorem. Every single one of them was some kind of Pythagorean theorem question. And that's basically, I think, all of the kinds of Pythagorean theorem questions you could ever see. Maybe not. Maybe somebody would be more creative than me, but I think those are about all of them. All of these green slides, I'm going to give you 2 sides, or I'm going to give you an angle and a side, and we're going to look for another side. Okay. So our question here is, what's this other side? So for all of these, we're going to use trig. Okay. So we're going to have to decide, do we want to use so, ka, or toa? So all you're going to do is label your stuff. You go opposite the 24. That's the opposite. Opposite the hypotenuse, or opposite the right angle, that's the hypotenuse. And then I don't have anything over here for the A. This side is completely blank, so I'm not going to use it. Sine relates O and H. So we're going to write sine, and then our angle. The angle always goes right here, equals O over H. We just make that fraction, O on top of H. Remember, H always sinks to the bottom. H is always in the denominator. So X over 9. I like to put a 1 under here. It's like the invisible 1 denominator, because then I can just multiply, and it makes my life a little bit easier. It makes it easier to look at that as an equation and know that I need to multiply. So then you come over here, make sure you're in which mode? Degree mode. Let's clear out all of that trig. You can either type in sine or you can click on it. So sine of 24. Make sure you close those parentheses, and then times 9. And we get 3.66. Does that make sense? 3.66. Is that a reasonable answer for that short side? Yeah, because I know it's got to be smaller than 9, because 9 is the hypotenuse. Okay. How about 14? You guys talk me through this one. Yeah, absolutely. Mm-hmm. Mm-hmm. Sweet. And then what do I do? What math do I put in the calculator? Sweet. 37 cosine 16. And Victoria, I love that you put the 37 first. That definitely helps you make fewer multiplication mistakes, because here you don't have to put any parentheses in like I had to put in the last one. So as long as we've set it up right, we should hopefully get the right answer. Let's look at 37. 37. Ay. 15. What do I know here? Maybe somebody who hasn't chimed in yet. Anybody feeling brave, feeling confident? What's the... Yeah, go for it. Yes. Correct. It's almost as if those switch places. Yes. So go ahead. I'm sorry. Mm-hmm. So in my calculator, 12 divided by 929. We're still in degree mode. And that's the only complicated thing. That was brilliant. I love it. Isn't it kind of empowering when you finally figure out sine, cosine, and tangent? I think there's like a weird gratification in being able to do this when you first learn it, because it seems like such a foreign language when you first start. Sweet. That's exactly what that's supposed to be used for. What about number 16? What combination of sides and angles do I have here? This one is often my favorite one because I don't have to think about it too much. Do I have a hypotenuse or do I have two legs? The hypotenuse is over here, opposite that right angle, and I don't have any information there, so I can't use the hypotenuse. So it can't be sine, it can't be cosine. If you have the two legs, legs are gonna make you do tangent, okay? So I've got the opposite side and the adjacent side. Tangent of my angle, the angle always goes right there, and then O divided by A, O divided by A. So 22 divided by X. Just like in the last one, when Naja said we can't have that X in the denominator, right? When we solve our proportion, we're gonna multiply these guys and get tan 58 times X equals 22, then we would have to divide by tangent of 28 or 58. Divide by tangent of 58. So ultimately, the X and the tangent, those two things are just going to switch places. So in my calculator, I know that's kind of hard to read, we're going to do 22 divided by tangent of 58. And when you do that, hopefully you get 13.75. Can somebody double check that for me in the calculator and make sure I did that right? 22 divided by tangent 58. Sweet. We've got a couple more of these sine, cosine tangents. I want to hear from somebody I haven't heard from yet today. And I'm willing to wait. Who hasn't spoken up today? I'm so happy, Sev. Exactly. So my H is my hypotenuse, my O is my X, and then my A, that's always the hardest one to see, that's the 17. So I've got X, which is the O, and I've got 17, that's A. I don't have the H. So what am I going to use? Nice. Tangent of 48. So we want the O over the A. So flip that upside down. O over A. So the O is the X. So that has to come first. And then the A is the 17. That has to come second. I love it. So now what do I put in the calculator? Okay, so this is a proportion. It's just like if I had 48 over 1 equals X over 17. If I gave you that problem, what would you put in the calculator? Absolutely. We're going to do the same thing. We just have that weird little word tangent in there. So all you're going to do is tangent 48. And if you go into your functions, you can just click on tangent and it'll give you those parentheses. So tangent 48, and then close the parentheses. I got to get rid of my sign nonsense over here. And then you can put in your 17. I think you are correct. Let's see. 18.9. We have a winner. Take a bow. Yes. We need another brave soul. Who's going to try? Seb was. All right, Elise. Show me what you got. Awesome. Do we have anything for the O? Do we have a number here? Nice. Yep. Oop, I don't know why I wrote 27. You're on a roll. Okay, 37. Absolutely. And then how do I get the X by itself? So we want to divide by that cosine 37. That's the weird part. So that cosine 37 has to move to the bottom. It's almost like those two things switch places. So we're going to end up with 48 divided by cosine 37. Yay! 48 divided by cosine 30. Yay! I'm so proud. $60.1. Winner, chicken dinner. Okay, I need another super brave soul for a word problem. Oh my goodness gracious. This is going to get such huge props. No pun intended, since this is an airplane question. Get it? Props? And horizontal is the side-to-side one, right? That's what I'm finding. So what else? Victoria and Asia, you guys are both trying to talk. Absolutely. So it's climbing. It's going from the bottom and it's climbing. So that's how we know it's the 12 goes here. And that's the toughest part. And then where do I put that 500? You can't hear me? Uh-oh. Is my thing glitching again? Can you still not hear me? Am I moving? Okay, you can. So where does the 500 go? What does that mean? Sweet. So altitude just means how high it is. If it said the distance it had traveled, that would be the hypotenuse. And so that's what's the hard part about these questions is you just have to be able to translate them right and make a picture. And they're just kind of stinky. Once we have the picture, we're going to use sine, cosine, or tangent. Tangent. How did you know tangent? You did. Tangent 12 over 1 equals 500 over x. I think that's what we're going to get because this is the O and this is the A. So tangent of my angle always goes next to the tangent. And then we're going to go O over A. This is the numerator. This is the denominator. So 500 over x. And because we have that x in the denominator, what do we do with the tangent and the x? Divide. So we're going to do 500 divided by tangent of 12. Oh, you're finding all of my mistakes then. 500 divided by tangent of 12. Ooh, that's a big number. 2, 3, 5, 2. 2, 3, 5, 2. Oh, I didn't put an answer in there. Tangent 12 equals 500 over x because I didn't put a number in there for you. That is definitely the right answer. 2,352. Questions on that? This has been fast and furious. Is it clarifying stuff? Maybe a little bit? Okay, well, let's jump right into number 20 then. We've changed colors. So all of the blue slides were Pythagorean theorem. All of the green sides were trig. Now we're going to have these yellow slides, and they are all going to be inverse trig. Okay, all the yellow slides are going to be inverse trig. All that means is we're going to still use SOHCAHTOA. My internet. Are you guys still there with me? Okay, good. But I'm good now? Okay. So I had another class a couple of weeks ago that was like, you sound like a robot, Miss Doherty. You're really freaking me out. So let me know if I have a weird robot voice too. We're going to mark these exactly the same way. So is the 15 the O, the A, or the H? That's the O. We're going to go straight across like we're playing flashlight tag. That's the O. And then what about the 24? Is that the H or the A? Fantastic. So if we have O and we have H, we don't have an A, so we can't use cosine. We don't have an A, we can't use tangent. So we've got to use sine. Okay, so if you figure out what letter you don't have, that'll tell you what you have to use. We're going to do sine. We always put our angle next to the sine, right? But do we have an angle? So what we can do is put that little -1. Instead of that little degree symbol, I replace the degree symbol with a -1. And then we can, it is going to be -1 every time. So then the O goes to the numerator and the H goes to the denominator. All we're doing is this is sine, opposite over hypotenuse. Those last two letters make your fraction. So 15 over 24. That equals x. There's no multiplying. There's no dividing. There's no thinking, really. All you got to do is remember that if you're looking for an angle, you want to use that little -1. And I just kind of remember that -1 replaces the degree symbol. That's what I'm looking for. So then 15 over 24. Boom. That's it. That's all there is to inverse, sine, cosine, and tangent. It's such a breath of fresh air after we have to figure out all the proportion nonsense. So 38.7-ish. 38.7. So now you try. How would I set up 21? What do I know? What do I need to use? I've got the hypotenuse. That's always the easiest one to find. It's not the one opposite. It's the one adjacent. It's the one next door. It's like a hard right turn. So what do I have to use? Sine, cosine, or tangent? Cosine. I have no opposite side, so I can't use the other two. Cosine, do I have an angle or am I looking for an angle? Looking for one, so we're going to use -1. And then what goes in the numerator and what goes in the denominator? Sweet. In your Desmo calculator, everybody type in cosine -1, inverse cosine. You can find that under the functions button. So inverse cosine, say that to yourself, either out loud or inside your head. And then 8/11 and see what you get. Did we get 43? Yay! Okay, I need a voice from the gallery that I haven't heard yet today. Label the 20 and the 37. I've heard Elise. I've heard Victoria. I've heard Nasia. I've heard Sev. Michael, you want to give it a go? Joseph, Gabe, Sarah, Rayanne. Give me a go. All right. Show me what you got. Yay! So what do I have to put in my calculator? I'm so proud. Yay! Everybody put that in your calculator and see what you get, because half the battle is making sure you can program the calculator correctly. We set up a new TV yesterday. I'm not sure it's programmed correctly yet. I don't know. Programming is a thing. You did? What kind of dog did you get? Aww. What color is it? Who's going to be alpha, do you think? I used to have a golden retriever. He was a big golden retriever, but then we got a St. Bernard, which was gigantic. And the golden retriever instantly put the St. Bernard in her place, and he was alpha for the rest of their lives. It was really funny to see this dog that was 60 pounds smaller than the big one put her, set her right. I love watching that doggy dynamics. Did we get 28.4? Are we feeling a little more confident about these? 28.39. Yeah, 28.39. All right, I need a new volunteer. Who's going to show me what they've got? We've got such great class participation going today. What a great Friday. Isis, Alexis, Rayanne, anybody want to give it a go? know you know how to do it. I feel like I need the Jeopardy music. Do, 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 do. I wonder if Alexa could do that for us. Alexa, play cricket sounds.
Do you want to try some sounds? Cricket sounds?
Yes.
Okay, here's sleep sounds. Cricket sounds.
Oh, that's not what I wanted. Alexa off. All right. Anybody then, if we don't have any volunteers that are new, some of our tried and true voices. Ka. Mm-hmm. Why? Absolutely. So do I put an angle or do I put the -1? Why? Yes, ma'am. And then what? 18 over 24 equals x. That first letter always goes in the numerator. The second letter always goes in the denominator. H always sinks to the bottom. O is like a bubble. It rises to the top. And then the A fills in. Okay. So cosine inverse 18 over 24. Drum roll, please. Da, 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 da. Did we get 38.5? I can't make you share your screen, but hopefully everybody put that in. You can go here, inverse cosine, and then 18 divided by 24. Bum, bum, bum. Oh, I didn't get that. Oh, it's 23. That makes a world of difference. So, yeah, reading carefully is important. Sometimes that's my challenge, especially on Friday when I get going and I'm excited. All right, 24, guys, because I want to get down to the hard problems. So we're going to label this O, and we're going to label this H. So is that sine, cosine, or tangent? Sine. So we're going to do sine inverse because I'm looking for an angle. Hypotenuse always sinks to the bottom, and O's always rise to the top like bubbles. Then boom, you put that in the calculator. Can somebody confirm that it's 77.3? That I didn't do anything weird? Anybody confirm that? Uh-oh. I hate it when Desmos is weird. Honestly, I think Desmos is always weird. When we first got Desmos a couple years ago, I thought it stunk. Now I'm coming around to it, but yeah, okay. So let's look at 25. I'm gonna do the same thing, gonna do it fast. I've got my O, and I've got my A because I've got two legs. So if I have legs, that's automatically tangent. So I do tangent -1 because I'm looking for an angle. And what rises to the top like a bubble? The 7. So 7 over 5. Put that in your Desmo real quick. Hopefully it's not being silly. Inverse tangent 7 over 5. Inverse tangent 7 over 5. And see if I'm correct, 54.46. Woohoo! All right. Picture time. What do I do here? because this is a different yellow. I don't know if you can tell, but it's like a different yellow than the other ones. That means we might have to do something different here. So now we've got to choose, do we want Pythagorean theorem because we're looking for sides? Do we want inverse trig because we're looking for angles? Or do we want regular trig because we're looking for sides, but we're given an angle?
Well, we already have an angle, but we have a side, and we're on this angle, so we can trig.
Exactly. So if I have this 30, right, I'm going to go opposite, and that's the 168. So what's the x? Is that adjacent or hypotenuse? So it is the hypotenuse because this is my right angle. Even if it's not marked, like that's my right angle because we know that this tower, whatever it is, goes straight up and down. In an ideal world, we don't build things like the Leaning Tower of Pisa. We build things straight up and down, which means they meet the ground at a perpendicular angle. So in real life problems, you can always put a right angle right there by the ground, okay? As long as something's standing up straight. So that means I have the hypotenuse. So do we use sine, cosine, or tangent if I have O and H? I don't have an A. I don't have an A. So I have to use sine. So sine, what goes next to the sine? The -1 or the angle? Am I looking for an angle or am I looking for a side? I'm looking for a side. So that means I put the angle here. If you have an angle, you always put it next to the sine, cosine, or tangent. And then you use your sides to make your fraction. One of those sides rises up to the top like a bubble, and the other one always sinks to the ground like an anchor. Which one goes to the top and which one goes to the bottom? Fantastic. I put that over 1, and because my x is in the denominator, what magic do I have to do when I solve that proportion? Divide. Because the x is in the denominator, we're really going to divide. We're going to put 168 divided by sine of 30 into the calculator. And what do we get when that happens? 168 divided by sine 30. I know it should be bigger than 168. Can somebody confirm that what I got was right? 336? Yeah? 336. Awesome. I think this is the last question. Looks like a baseball field, or at least part of one. So what do I know and what do I need to use? Because that's half the battle. What are the two things I know? I definitely see a triangle in there. And what are the I see a side and I see an angle. Nice. So we're automatically thinking either ABC or OAH. Because I have that angle, I'm leaning towards OA and H, right? We're given that angle. So what's the 5? The H, the O, or the A? Five would be the O. I take a flashlight from the 30 and I shine it straight across. That's the opposite side. And what's the radius that I'm looking for? Is that A or H? Nice. I don't have an A, so I can't use cosine. I can't use tangent. I've got to use sine. Sine of my angle. That angle always goes in there. And then 5 over x. The bubble always rises to the top and the h always sinks to the bottom of your fraction. Because my x is in the denominator, we've got to switch these two things, right? So 5 divided by sine 30 equals x. in your calculator. Hopefully you got 10. Did you get 10? Cheers from the gallery. Yay! Way back 30 minutes ago, we were asked to go back to slide 5. So let's look at slide 5 one more time. We had an equilateral triangle, so we knew that angle A was 60, angle B was 60, and angle C was 60. We knew that the 60s were cut in half to make 30 and 30. And we knew that all the sides were the same, 16, 16, and 16. If the angles were cut in half to make 30, then the bottom side can be cut in half to make 8 and 8. So we did Pythagorean theorem, 8 squared plus x squared equals 16 squared. And I could write that. 8 squared plus x squared equals 16 squared. The first thing you're going to do is subtract 8 from both sides. So that's how we came up with that. Does that make sense?
Sorry.
Gotcha, okay. So I know you built a rectangular deck and we're looking for the diagonal. And the deck dimensions were 10 by 23. So 10 by 23 are our side lengths. Those are the legs. And we're looking for the hypotenuse. So the equation would be 10 squared plus 23 squared equals c squared. Class is almost over. We've got like 30 more seconds. How are we feeling? Do you think that with all of this review that you can work on a test and see how it goes? Maybe. Let me explain how the test works, okay, in my last 60 seconds of class. In today's folder, there was the warm-up, okay? So your warm-up link is there. This is your link to the test. The test is 20 questions. You have 3 attempts, okay? But the test is pulling from question banks. So number 1, like the first question is always going to be similar, but it won't be exactly the same for your first 3 attempts. What I'm looking for is 80%. If you get 80% on this test, I will give you 100% in the grade book. If you get less than 80%, you're going to get whatever grade you earn, okay? So this is my inspiration to you to keep taking it until you get an 80%. As soon as you have an 80%, know you have 100, okay? Does that make sense? Okay, you have 3 attempts. What we just did, I'm going to grade it for completion. Because I gave you all the answers, I'm not looking to see whether you got the right answers. I'm just looking to see whether you kept up and you did it a little bit on every question. Okay, that's all I have for you today. I am thinking I might drop a present off at everybody's house on Sunday morning at some point. So if you end up with a brown paper bag on your doorstep on Sunday morning, that's for me, and we're going to use those materials next week. Okay? I think it's going to be a super fun present. And if we had more time, I would explain it more. But we are out of time, and I don't want you to be late to your next class. So this will be a fun surprise for Sunday. Okay? I'll see you guys later. In an ideal world, Tuesday morning. Okay, but don't stress yourself out too much about it. Do as much as you can. Try to get that 80%. But if that is like killing you, stop. We'll talk about it Tuesday and I'll extend the deadline. Okay.